Hello everyone. Okay, welcome back. Today we're gonna solve a hard problem. Actually, yesterday's problem is also a hard one too. Okay, let's solve the hard one. Maximum fruits. Okay, first problem again. Harvested at most case steps. Okay, just read the statement. Fruits are available at some positions. Other. Okay. You are given two the integers array proofs where proofs is position and amount. It picks about I proofs at the position. Okay, understand. Okay, it always short by position. Alright, which is pretty good. You are also given an integer start pause and an integer k. Initially, you are at the position start pause. From any position, you can either walk to the left or right. It takes one step to move one unit. Okay. You can walk at most k steps in total. All right. You harvest on the first at the position. Okay. So clear. Return the maximum total number of fruits you can harvest. Actually, it will be harvest or harvest. Harvest.
Harvest.
Harvest. Okay. I gonna. I really like to say this word. Okay, check out the first example. That's that wasn't pi. Go to the one, two, three, on the three step, and you get 9. For example 2, you see, you're gonna gain 1, 2, 7. All right, you got exactly 14. Example 3, you got k equal to 2, but the output is 0 because you can't reach any position with first. All right, check out the constraints. Okay, it's really large, about 100,000. Okay, okay, and amount. All right. Okay. Oh, okay, understand. What this summarize this problem that is you got an array of fruits as some position with a certain amount of fruits, and you are given the start pose position. That means start at that position. You can move at most k step. You can move to the left or the right, whatever, but try to maximize the total number of fruits you can harvest. Uh, the statement is very clear, and we need to solve it. Um, just check it out. So for the ask position, you can move to this and the move to the left or the right. But I think the optimal is always move to it's mean if we have three options, the first one is try to move on to the left side, the right side, or try to move on the right side. This I mean the four case. This is the first case. The second case, the third case is you can move to the left a little bit to gain some fruits, then back, and that's more optimal than you go like this and this and this and this. It's not optimal because because um, the position is distinct, and that's mean we try to expand our range as much as possible. Uh-huh. In this case, the range is smaller than you go this and go there, right? That's right. Mm. So that this is the first case, and the second case go to the left and then go to the right. There are three case you could consider. But actually, what is the optimal one? Uh, this is very simple. You just get the sum from this position to k, and the same as the second case. But the third case, what you can do is just try. I think you could easily try some on the left then on the right. Okay, which we will try every each position on the left side, and the remaining step that's it's called your T step, and you need extra T step to go back to the position start. That means you got 3T, and the remaining is like this, and yeah, try on this position in the left side, and that's mean you got this remaining step and just get the maximum in that remaining. Okay, let me try like this for you. That this is the position start. Okay, you go to this ET and you go to this and you back to this. It called you 2T, and you can go to display. That's a K minus 2T, and we should try on the T position. Yeah, and the T position here is actually a position that contains force. And how to calculate this sum, and this sum actually you could use mm, as a prefix sum, right? A prefix sum in order to calculate a sum in a range in O1, left and right in O1. Use prefix sum because the first amount array is not a constant. It constant. This means it's not change. Okay, in O1, and actually we need to find if we try T. So what is the position? This position. What is that? There's a trick. We could use binary search to find this place, but actually we don't need to do so because as we try every T to the right side, that means T increase. That means K minus 2T is decrease, and it's just go to this. Let's go. That means when T go to this, and then K minus 2T is the same direction. You understand that? So let me try it again for you. Okay, this is S, this is T1, and this is T2. So this is the position K is minus 2T1, and this actually this position K minus 2T2. Why? Because T1 is like less than 3 2, so I mean the T here is distance, not the actual position. Sorry guys, the distance. Okay, the distance is T1, this is T2. This I made it up, I don't care about it. Okay, and this is K minus T2, and this K minus this K minus T1, not 2 to 1, and this is K minus 2 T2. Because of this, so we can figure out minus T1 actually larger than K minus T2. So in the relative position, as we increase the T, so the K minus 2T is decreased, but the decrease, so the range is shrink to the the right side. Okay, it's really reasonable, and actually the same case as you move T to the left side, that happened to K minus 2T the right side. So we could use two pointer instead of use binary search, because you O and log, and with two pointer it's only ON. So okay, now gonna implement this using Python. All right, first we need to calculate the prefix sum. Okay, I gonna do slice prefix sum is like this, and actually is there a function? Is there a function? I think no. The first element and with sorry, I'd love to use whatever. No, not mine. The first element is push 0 1. Okay, 4 in range 2 to length up. Actually, push. Alright. Prefix sum 10. Prefix sum minus 1 plus push I1. Okay, we got the prefix sum right now. Gotta write get sum here, left to right. If left side 0, I'm gonna return the sum of y. Now return the sum y minus prefix sum of L1. Okay, we got the get sum, and the case 1 that's on left, on to the left side. So first of all, we need to calculate the start position where it plays uh, easily. Uh, the first case I want to do the answers is 4 each in range, length of cruise, and this amount, and the cost and the amount is like cruise I. Okay, I'm gonna reuse this code on left to see. All right. Case on left, if the left side is like the start cost minus cost is like less than, must be this is on the left side, so this must be larger than 0 or equal to 0, and it also must be less than the k. So I got, we could, yeah, sum left and sum right on 0, sum left plus amount, the same as this. On the right side, that means the pause must be larger than the start point, and this distance must less than k. So right plus amount. That's this. And sum left and sum right. Don't forget the case 3, and that's the case 4. If 3 is to left, then all right. This is the to right, and then all left. We could use 2 pointer, point left and point right. The left side in, as we go to the left, um, as point left, this game, point left it is as we go to the right. So initially it must be okay, it must be 1, and point right must be length and push anyway. That's one. Okay, we go to the right side here, so the left pointers is increasing. Like we're gonna use a y. Check. This only happen when the post is larger or to the left. We go to the left. That means go to this side. That means the post must be sorry. As we increase by this, as we go from left to right. So when we that means the distance is decreasing, so that means the t is increasing. So the point rise is 0 to all right, got it. Pulse is actually less than or equal to the start pulse. Let's be yeah, we could continue like while j point right is less than length of pulse for sure, and uh, and uh, and you know the distance is from the start pulse minus pulse, and we need to this t, the t is like start pulse minus pulse, and because k minus 2 plus t, this is the remaining space. The remaining is we calculate the distance from this, as mean and increasing physics wise still less than or equal. So I gonna to check if the position of the pointer right and 1 minus start pulse. I think we should find the position of the previous. Okay, but I don't do it right now. Right here is point right push, and um, the push pointer rise and one is actually less than start pose. I'm gonna increase pointer. That's it. We need to do that. And after we reach this position, this is actually the remaining space. The remaining, and this is the distance from the. Okay, that's it. Uh, still, the distance is still. The remaining is still larger or equal to. So we keep increasing the distance. So PTR plus one. So, all right. So, uh, F on PTR minus 1 actually is minus 1. Oh, God. That is this. So, I'd love to get the sum. Get the sum of answers, like I mean the answer, mass, please, mass the answer with the get sum from uh, the actually the calculation to point right. That's the point minus one. That's right. Yeah, that is the case that okay, this is pause as we start pause as we increasing, then the distance it increasing to oh, this is true. Okay, again, got this line because this and this and this and if you go to the right, it's a bit this so the distance increasing to oh right. Okay, y pointer left on the left side is Fn. Actually, it can pass I for sure, right? And and actually proves the t. We need to calculate the t here is like this the pause minus start pause and case minus 2 plus minus multiply t is this remaining distance is still large than the distance from the start pause minus pause point to left 0. So we're gonna increase the point to left. So that's it. There's thing is can pass the it just can pass positions of start pause. This might be on the left side of start pause. Uh, if like this. Actually, this sorry, but since remaining space is uh this is the remaining space and this is union and this must increase when the remaining space is less than this like increasing. Oh, that's right. But in this case, when this is the remaining space and this, so we're gonna start for sure, for sure. But remaining space is just increasing. Remaining space is this. So just oh, that's right. Okay. Um, there's thing. the left side, the pointer left, the push position pointer left is must be less than or equal to start pose, right? So if that's, we could get the answers like mass of answers and get some from pointer left to actually to pointer I. That's the idea. Oh, that's done. Be done. Answers. So we got the answer, but I don't think this might be right. So I got a big bug. So okay, check it out. Um, left, then right. So to go to this. Well, sorry, and why too slow? Check. One, two, three. Got three and bus. So 1, 2. It's got to be. So y is 1, 0, 1, 0. Okay, got it. So it's 8. And, to right. Oh, y is 8. Check to right. But why 8? What? But why? My bad, my bad, my bad. Well, this is an interesting case. To the left and right. To the left, 1, and you can reach point. Really? It's actually this one. But why? My bad. Why? Why? Why you just keep doing stupid thing like this? Why? Tell me why? Ain't nothing but a mistake. Tell me why. Why so low, man? Check it out. Right. Actually, we don't need this case to. We don't need this case, right? We don't need this case. Actually, it already served in this too. So I want to turn off this case. And still, it must be still be true. If not, we need to think about it again. Ah, sorry. That's why we need it. We need it because it's only true when we start at a position that already have the fruit. Now I'm gonna try the solution if it would be correct or not. I think the solution is so clear and yeah, got it. It must be right. Anyway, right. Just think how to optimize this. But I think it's the O answer is okay. Bisect. Okay. The cubic sum. The sum. Oh, right. It's much simpler, but actually in my case, it's more clear. Understand? Just check out the editorial if you could give me more idea to present this problem in the future. No, not by research here. Okay, check out this. Since the pro's positions are always sorted in standard order, we can efficiently determine how many pro's fall within an interval using by research for sure. The main challenge is to find the interval. Right. We follow the strategy. Right. Moving in one direction first and then turning around, then turning around. Yeah, that's a good term. This works because the clues can only be picked once, and covering a wide range increases the chance to collect more clues. Right. There are two main movement patterns to extend in one direction, and K minus X step in the opposite direction. When X is 0, simply move to one direction. That's right, that's so right. This explanation is good as me. Have a nice day.